Example 2 says, find f prime of x if f of x equals x cubed minus x. F prime of x being the first derivative of the function f of x. The definition of derivative says f prime of x equals the limit as h approaches 0, f of x plus h minus f of x all over h. That's the definition of derivative. That's something that you need to have under control. It's got 3 pieces to it. Piece 1 is f of x plus h. That we have to make. Piece 2, f of x, that's what we're given. Piece 3 is h, and that's just h. Alright, so the 3 pieces, we already got 2 of them given to us. F of x is given to us, h is h, so it's given to us. The only thing we have to make is f of x plus h. So when I'm told to find f prime of x using this technique, first thing I do is I evaluate f of x plus h. F of x plus h just means you change all the x's to x plus h's and then carry out whatever powers and addition subtraction there is to it. So x plus h is going to become x plus h cubed, and minus x is going to be minus x plus h. So just apply good algebra here. Substituting in your expression x plus h for the x's, whatever's happening to x's is happening to x plus h. We have a binomial cubed. Pascal triangle numbers for a cube is 1, 3, 3, 1, right? So, 1 x cubed h to the 0 plus 3x squared h to the first plus 3xh squared plus 1x to the 0 h cubed. That's what that part is. I got minus x plus h, that's going to be minus x and minus h. Be careful that if there's subtraction in a problem, you're always doing x plus h. There's always going to be a distributed property happening there. Make sure the subtraction distributes. So if I want to simplify it, f of x plus h as much as possible, these two terms can be a little prettier, right? So x cubed would be the prettiest version of 1 x cubed h to 0. 3x squared h looks pretty good. 3xh squared looks pretty good. 1x to the 0 h cubed looks better as h cubed minus x minus h. That expression simplified is what goes right there. Now the other thing about this, and you can write it out at this point, you put limit, all this other stuff, but it's always minus f of x. Alright, when you're dealing with polynomial functions, this is what happens with polynomial functions. Here's what f of x is, x cubed minus x, right? If I subtract that, if I do minus x cubed minus x, what sign is x cubed?
Negative.
Negative. What sign is x?
Positive.
Positive, right? So watch this. Minus x cubed and plus x. When you deal with polynomial functions, the pieces of f of x should be part of f of x plus h every single time. You're going to be subtracting f of x. So all this top stuff does is all your f of x objects that show up in f of x plus h are going to cancel because of the subtraction. So what's left on top is just a bunch of terms containing h. So you can even simplify the top down as much as that before you actually start working out. So this right here, 3x squared h plus 3xh squared plus h cubed minus h is what f of x plus h minus f of x is equal to. Okay, because again, f of x plus h always contains f of x. Always. If you did it right, it contains it. Alright? So when you subtract f of x, those pieces are going to go away. What's left over is the pieces that aren't f of x. That's what the top is. So at this point, if I do my f prime of x, I simply put what's left over from f of x plus h minus f of x on top. 3x squared h plus 3xh squared plus h cubed minus h. All over our magical h that's just on the bottom because it's part of the process. Okay? So again, simplify the top. It's some algebra. It's not super difficult algebra. Binomial expansion theorem makes the multiplication a little bit simpler. And again, knowing that f of x should get out of there should make that part simpler. Once you get to this point, oh, I left my limit off, didn't I? Limit as h approaches 0. Alright? I can't put 0 in right now because I've divided by 0. But I've got an h, 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 and h. Everything has h on it. So every h can be reduced by 1. So I'm going to get limit as h approaches 0. And h on the bottom goes away, so it's just over 1, no more fraction. Everything else just loses an h. So I'm going to get 3x squared plus 3xh plus h squared minus 1. Okay? We have some h's to the first power, other h's to the second, third power, whatever. Every power needs to be accounted for, but all that happens is all the powers of h decrease. So h to the first goes away, h squared drops to h cubed drops to h squared, h drops to 1. This is 1h. Make sure you get the minus 1 there, it does matter. Alright? And the h on the bottom equals 1. Division by 1 doesn't do anything, so you can leave that off. Alright? But this minus 1 does matter, so make sure you put the minus 1. At this point, if I substitute in a 0 for h, this term and this term both go to 0, so my answer for f prime is going to be 3x squared minus 1. That's my slope formula for that function. So if I'm anywhere on this graph, if I know what x value is, I can find the slope. At the point 0, 0, that'd be a point on that graph, right? The slope is negative 1. At the point 1 comma 0, the slope is 2. At the point 2 comma 6, the slope is 11. Right, like that. So any point they give me, I can find the slope of the tangent line just by using this formula. Change x to the x value, and then that's the slope. That's the usefulness of this. That's what we're going to be using it for. And as we continue on to this class, we're going to find more efficient ways to get from here to here. Enough, it's so efficient that you're going to be so mad at me when we find out how to get from here to here with all this mess in the middle. But it makes you better people to go through all this algebra necessary to do this in calculus. So practice the algebra way, and once everybody's really good at that, then I'm going to show you a few shortcuts you can do to get answers more efficiently for some problems.